Hello and welcome back to Apt for You. In this particular video, we are going to discuss a new problem from arrays. And the problem statement says that we have to find out the smallest subarray with sum greater than x. So, before we start discussing about the problem, let us understand what the problem actually is. So, the problem statement says that we need to find out the smallest subarray whose sum is greater than a particular value x. So, to be more precise, let us directly jump into the example. So you can see that you are provided with an array A, and the size of the array is basically 6. You can see there are 6 elements: 1, 4, 45, 6, 0 and 19. You are provided with a number x which is equal to 51, and now you have to find out what is the minimum size of the subarray whose sum of the elements will basically exceed 51. That is what we need to find out, isn't it? The smallest subarray, you can see the smallest subarray. You need to find out what is the size of the smallest subarray with sum whose sum of the elements will be greater than the given number x. So if you focus on this particular example, what happens is basically, you see, if I consider this subarray 1 plus 4 5 plus 45 50 plus 6 is equal to 56. So what sum did I get? 56, and obviously 56 is greater than the value of x, which is 51. But the size of the subarray is how much? It is 1, 2, 3 and 4. 4. This is the size of this subarray. Can I have a much smaller subarray, okay, whose size will be less than 4, and at the same time its sum should be greater than x? So suppose if I right now ignore 1, now if I consider only this subarray 4, 45 and 6, so this sum was 56. The sum of this subarray comes what? 44 plus 45, 49 plus 6, 55. And we can also say that 55 is also greater than x. Also true. And the size of this subarray is how much? 3. Can you have a much smaller subarray whose size will be less than 3, and at the same time the sum of the elements should be greater than x, that is greater than 51? So now if suppose I ignore this 4 and I consider this only, so this is again 51, but it is not exceeding 51. So this cannot be the subarray, right? So what can I do next? Now what can I do is basically try considering this subarray. So 45, 6 and 0. At the same time you can see its sum is 51, but it is not exceeding 51, which is x. No problem. Go ahead. Now you got how much? 45 plus 6 is 51, plus 19 is how much? So 51 plus 19 will give you 70, and obviously this is greater than x, but at the same time the size of the array is how much? 1, 2, 3 and 4. 4. Size of the subarray is 4. So you found out that these are the cases wherein I found out that the sum can be greater than 55, right? This case 1, case 2, case 3. Out of this subarray has the smallest size, at the same time satisfying the condition greater than x, isn't it? Which subarray is this one? 45, 4, 45 and 6, this subarray, isn't it? I hope you got the point. 4, 45 and 6. You see, I found out that this subarray, if I take its sum, will be equal to how much? 55, and this is basically greater than x, satisfying. At the same time its size is 3, and you cannot have any subarray smaller than size 3 whose sum will be 45. You can just check, right? So this is what we have to do in this particular problem. Now the question is, how do we approach this particular problem? So let me show you the solution. So you can give a try, right? I have tried this several times, and this is the multiple attempt I am trying to solve this question, okay, because I have already solved it many times earlier. So now if I consider solving this particular problem, let us design a good example. So suppose I need to find out a subarray whose sum is greater than 9, and suppose I have here elements like 3, I have elements like 3, 2, 5, or you can have again 2, 8, you can have 10, you can have 15, right? So we need to find out a subarray whose sum is greater than 9. So basically we want to find the subarray whose sum is 10 or above, right? So sum should be greater than or equal to 10. This is what I want my sub array to be, right? So what can I do is, you can see initially I'll be using two pointers, I and j, right? Pointer I will be standing at this point, pointer j will also be standing at this point. What are the indexes? 0, 1, 2, 3, 4, 5 and 6. Now just focus on the approach. What will I do? I know that my sum should be basically greater than or equal to 10. So as long as it is not 10, I can just start adding the elements, because I am standing at this point I. This is my pointer I. Standing at this point, I can include 3 with me in my bracket. So I'll be having 3. So you consider 3. Go ahead. So 3 is still less than 10. True. So you can include this 2 also in the bracket. 3 plus 2 is 5. 5 is still less than 10. True. So you can still include this 5 in your bucket. So 5 plus 5 is how much? 10. So now finally you reach the criteria, that is greater than or equal to 10, which means right now you found out that a combination exists from 0th index to this index, these elements, right? So basically what I want to say is, you found out a sub array whose sum has basically exceeded 10 or greater than or equal to 10, exceeded 9, that is greater than or equal to 10. So what I can do is, as I said, I'll be using two pointers. Suppose integer I is equal to 0, j equal to 0, and I'll use a variable sum to keep track of my sum of the elements. Now how long will I go? Now we know that my pointers will traverse this entire array, right? And the size of the array is basically n, suppose n. So while suppose j less than n, right? Because my j pointer, you can see, is keeping on proceeding. Okay, my I pointer remains fixed at one place for some time, and it is the pointer j that I am going to move ahead. So to be more precise, what happens is, you see, initially I have my I pointer standing at this point, j pointer standing at this point. So I will check that while if your sum is less than x or less than or equal to x, which means if you are still less than or equal to 9, because my x is 9, isn't it? Then what will you do? You will keep on adding elements in your bucket. So what will I do? I'll do sum s plus equal to array of j and j plus plus. I hope you got the point. So what will happen by this way? By this way you keep on adding elements as long as your sum is not 10. So initially my I is pointing here, don't worry, j is pointing at this index 0, right? Both are at 0. So my j pointer will start from here, will go till there. So that's why while j less than n. So initially my j pointer is here. I'll come inside and check that, okay, is the sum less than equal to x? Definitely true, because sum is right now 0, right? So better I'll be using a variable s here for sum, right? So sum is less than equal to 0 right now, isn't it? So what can I do is, basically I can include this element, isn't it, by this statement, s plus equal to array of j. So what will happen? S was 0, now you included 3, so it will become 0 plus 3, that is 3, and j plus plus. So j pointer is now pointing to this element 2. So again you go back to the while loop. Is sum less than equal to x? Definitely sum is 3 and it is less than equal to x, which is 9. True. What will you do? You are asking it to include the current jth element. J is 2, this index, right? J is pointing to this index, so you will include this element 2 also. So 3 plus 2 will become 5, because you are adding to sum, isn't it? S plus equal to array of j. So 3 plus 2 becomes 5, and j plus plus, j will now point to this element 5. Next time you come here, is your sum still less than 9? Definitely yes, because my sum right now is 5 and it is less than 9. So what will you do? You will again go inside and you will basically add the current jth element. The jth element is what? 5. Add 5 to the current sum. So 5 plus 5 will become how much? 10. And do j plus plus. So j is now pointing to which index? This index, right? So I hope you got the point where j is right now pointing to. This is I, where I is pointing to, and this is where j is pointing to. So you have traversed this entire region. So right now you can see that when my sum, when I find out that, okay, let me just change the color of this frame. Yeah, when I find out that my sum has basically exceeded x, that is, it has become greater than or greater than x. So greater than x, isn't it? X is 9, which when it becomes greater than 9 means greater than or equal to 10. So right now you can see this is the window that I considered from 3 to this element, right? I have included these all elements. my j is pointing to this point, and till now I have included all the elements under in 0th index, 1 index and 2 index, because 5 plus 2 is 7 plus 3 is 10. So now what will you say? You will try to see that okay, I have basically I have basically found out a subset. Okay, I have found a subarray whose sum is greater than 9. Can I compress it? Can I compress this window frame? For that, what will you do? You will start eliminating objects from the left side, right? So this is 3. Remember, this is 3, not minus 3. 3. So you will start eliminating objects from the right side. So for that, what will I do? Again the same thing. Because you see, what can happen is, suppose there is an example like you have 3, you have 6, and suppose you have 9. Now I want okay, not 9, suppose 8. Now I need now my x is equal to 9. I need that my value of subarray should be greater than 9, that is at least 10. So initially what will I do? I'll pick up 3. Again I'll pick up 6. So 3 6 is 9, still not greater than 9. You will include 8 also. So 3 plus 6 plus 8, you included the entire subarray. So 3 plus 6 plus 8 will give you how much? 17, right? But you can see that although this 17 is greater than 9, it is correct, it is fine, right? The size of this subarray is how much? 3. But still, if you eliminate this 3 from the front, you will come out with a subarray 8 and 6 only. 6 plus 8 is equal to 14. This will also satisfy the condition of greater than x, and its size is 2. Then obviously this should be my area of interest, that try to reduce the size. Okay, I hope you got the point. So you will find that initially when I am adding the elements, then my sum will become greater than the required value of x, greater than the value of x. But then I can reduce the size by further deleting the front elements. There might be some cases when if you remove the first element, you will find out that okay, the sum of the remaining elements still is greater than x. Then obviously I'll try to go as minimum as possible, isn't it? So for that particular reason, whenever I consider that I have found out a bracket, or I have found out a combination or a subarray whose sum is greater than x, I'll stop. Okay, you will come out of the while loop, because this while loop will stop, isn't it? Whenever you find out sum greater than x. And what will you do is basically again you will write a while loop, and what will you do here? You will check whether sum is greater than x. Okay, now you will check whether sum is greater than x. So what is my x? X is 9. What is the sum you calculated so far? 10. Now obviously if you are entering this while loop, which means you have found a certain combination whose sum is greater than x. So it becomes important to keep track of the length of the current combination. So length is how much? So length will basically be, length is how much? Length is, you can see j is pointing to this index. J is pointing to this index right now, which is index 3, and minus 0 is how much? 3. So you can see the length of this subarray that you have basically found out is 3. So j minus I. So what will I do is I'll check here if j minus I is less than minimum. Now what is minimum? Initially I'll declare a variable minimum, integer minimum equal to integer max. Okay, some very large values. So remember, when I am entering this while loop, it clearly indicates that I have found a combination of subarray whose sum is greater than x. So better keep track of the size of the current subarray that you have considered. So how will I keep track? J minus I. If j minus I, j is how much? Pointing to 3. I is how much? Pointing to 0. Right? I is still pointing to 0. You can see this point, and j is pointing to this point. So 3 minus 0 will give you 3, and you can see the size of this subarray is 3. And minimum is very large number. Right now minimum is very large number, int max. So obviously j minus I is less than minimum. So what will I do? I will initialize minimum to j minus I. So initialize minimum to j minus I. Done. What next? So now I have basically kept track of the current subarray size. So my minimum value will be updated to how much? 3, because j is 3, I is 0, 3 minus 0 is 3. Done. This is the value of minimum right now. Minimum. Now what next? You will now try to remove this element. Because you found out a combination whose sum is greater than x. Now you will try to see that okay, if on removing this I can still get a combination whose sum is greater than x. For that particular reason, what will I do? I will say if you can just say sum minus equal to array of I. You can just remove that element, the front element, okay, and you can just increment the pointer I plus plus. So I hope you got the point. What will I do, you see? So to make it more clear, what I have done is basically I have removed this from my sum, okay. So remember, right now my sum was how much? Sum was 10. You remove this element, array of I. So what will be the value of sum now? Sum minus area element in the front, that is 3, becomes 7, right? I plus plus. So now I is pointing to this index. Okay. So now again your sum is 7. You will come back. Is your sum greater than x? Sum is 7 and we know that x is 9. So false, which means you are not going to delete any more element from the front. Got the point? Because you can see that right now my sum is 7 and my value of x is 9, which indicates that the value of sum is not greater than 9, which means you cannot delete any more element from the front. So what will I do? Come out of the while loop, and now again you will go back. Now still you can see your j is pointing to this index only and it is still less than n, so no problem. Again you will, what will you do? Right now you found out that you have a sum and your value of sum is basically less than x, right? Because you are right now focusing on this subarray 2 and 5, and this subarray you will find out that the sum is less than x. So we know that whenever my sum is less than x, I'll try to include more elements. So right now what will you do? If sum is less than equal to x, include the next element. So include this jth element. So when I include this jth element, what will my sum become? Sum will become again 9. So sum will become how much? 9. And now my j will point to the next element. J will point here. Again you come back. Is your sum less than equal to x? True, because sum is 9, it is still less. What will you do? Your sum, you're basically, again you will include this current element. So your sum will become how much? 9 plus 8, 17. And j will, again you will include this also. Now j will point to the next element here. Again you come back. Sum is how much? 17. Is it less than equal to 9? That is x. False, which means now you have basically found out a combination whose sum is greater than x. So what is the combination? The combination is 2, 5, 2, 8. This one. So what, again, as I said, after you find out a combination, you will try to remove element from the front and see whether you can still get a sum greater than 9. So sum is how much? 17, greater than 9. True. You come inside and you keep track of this current subarray. What is the subarray value? J is pointing to 5, I is pointing to 1. 5 minus 1 is 4, right? And minimum is 3. So you obviously 4 is not less than 3. So minimum will still remain 3 only. And what will you do? Sum minus equal to array of I. Array of I is pointing to 2. You basically remove this 2 from the combination. Removing 2 means your sum becomes 15. You can see you still have a sum which is greater than 9. Again you come back here in the while loop. Okay, again you come back in the while loop and what will happen? 15 is still greater than x. True, which means you can still remove more elements from the front. Come inside. J minus I. So what is j? So right now you see after you remove 2, the I pointer will increase here, right? I is pointing to this index 2. So, and these no longer exist. Remember, these things no longer exist. So my I pointer is pointing to 2, j pointer is pointing to 5. So 5 minus 2 is how much? 3. You can see after you remove 2, the size of the subarray will become 3. 5, 2 and 8 only, right? So obviously this again is a possibility wherein you will get the sum to be greater than 9. So but you can see the combination still is equal to minimum value only, no problem. Then what will you do? If j minus I less than minimum, then you will update the value of minimum and then you will just remove the front element. Again I will be removing the front element. I will remove 5. So once you remove 5, your I pointer will increase to the next element, next position. That is here. I pointer is now pointing to this element 2. And my this value will be reduced to 10. What the point? Because I am doing sum minus equal to array of I. I plus plus, I did it accordingly. Again go back. Is your sum greater than x? Definitely true. Yes, it is greater than x. So what will you do next? You will again remove the front element, right? But before that you will keep track of the current subarray size. Current subarray size is nothing but 5 minus 3, which is nothing but 2. Obviously it is less than 3. So update the minimum value to 2. Done? What next? Remove the front element. This is for removing the front element. So now if you remove the front element, means you are removing 2. So if you are removing 2, what is happening? This becomes 8. Got the point? I plus plus means now I will point to the index, the element 8. Done. What next? Now is your sum greater than x? Sum is 8 and it is not greater than x. False. So what happens? You will just come out of this while loop. You will come out of the while loop. You will come out of this while loop, and you can see you will just go back again. Is your j less than n? Obviously j is still less than n because I have not traversed the complete array. Come inside. Is your sum less than x? Obviously sum is 8 less than x, which means you can add more elements to your bag. So right now remember, my sub array size is only 8. So what will I do? I include this 10, right? So sum plus array of j. So 10 was included, so sum becomes how much? 18. J plus plus. J will now point to which element? The next element. J points to the next element. What happens? Come back. Sum less than equal to x? Definitely not. Sum is 18, so becomes false, which means you no longer will enter the while loop. So what will you do next? You will come in this while loop. Whenever our sum exceeds the value of x, we come inside. Here, isn't it? You will try to remove the element from the front. So obviously we will first of all keep track of the current size. So the current size will be how much? J is 6, I is basically pointing to 4. 6 minus 4 is 2. Minimum is still 2, no problem. Remove the front element. Sum minus array of I. Array of I means 8. Remove this. If you remove this, 8 will be removed from the sum. It becomes 10. What's the point? I plus plus. So I will now point to the next element. So remember, in your window you have only this element. Again come back. Is your sum still greater than x? True. Obviously sum is greater than x because sum is 10 and it is greater than 9. Find the size of the subarray. Sum of the subarray size will be how much? 6 minus 5, which is 1, and obviously it is less than 2, isn't it? So minimum will be updated to 1. Sum minus array of 5, so you will remove 10. So this will become 0. I plus plus, so I will come to the last index. Here. Go back. Is your j less than n? Definitely yes, j is less than n because this index value is less than equal to n minus 1, right? This index value is n minus 1. It is true. J is less than n, and because I'm in the last index, come inside. Is sum less than equal to x? Definitely true. Sum is less than equal to x. So s plus equal to array of j. So array of j is how much? 15. Sum becomes 15. J plus plus, so now j will exceed the value of the range of this. So again you go back. Sum less than equal to x? False, because sum is now 15 and it is greater than x. Now you will come into this while loop. If you come into this while loop, what will happen? You will again check whether sum is greater than x. Definitely it is greater than x. So what will you do? You will try to keep track of the current subarray size. So current subarray size is nothing but only one element, isn't it? So j minus j is right now pointing to the next index, that is 7, isn't it? 7 minus 6 is how much? 1. So minimum is 1 and it is still 1 only. No problem. So what next? Don't do anything. Just remove this element from the sum. Remove 15 from the sum and I plus plus. Now I will also go ahead. Now if you come back, the value of j is less than n becomes false, which means you have already traversed the entire array. What is the minimum value that you kept track of? Minimum value was 1, so definitely that should be returned. So basically after my traversal is complete, after this while loop, you should return minimum, because that keeps track of the minimum value, right? So I'll just compile and submit this. Okay, so I'm writing sum minus equal to array. It is actually s, isn't it? It should be s, and yes, we can compile it. I have basically solved this problem several times, right? So you can see the compilation is successful, because here obviously it is obvious that the minimum subarray size, whose value will be greater than 51, is nothing but considering this subarray 4, 45 and 6, isn't it? So that's why you got a subarray size 3. Now if I submit the code, so you can see the compilation will be successful. Okay, so somewhere I am making a mistake. Let me just check where is my mistake. Alright, so I noticed a very silly mistake. You can see that minimum equal to j minus 1. We should write j minus I, isn't it? So there was a typing mistake. It should be j minus I. Now if you submit the code, it will work fine. So really it's very frustrating whenever we do such mistakes, and you can see unnecessarily we increased our number of attempts and the accuracy was reduced. Anyway, so yes, the problem is solved successfully, and this is how you can basically solve this particular problem. Yes, I didn't get the score because I had already solved it in the first previously, and I have already been awarded the score earlier, so they don't give you score again and again. And yes, it seems quite interesting that GFG has basically changed its interface. So anyway, this is how you can solve this particular problem, and obviously we didn't use any extra space, so the space complexity here is obviously order of 1, time complexity is order of n, because we are just solving this particular problem in one traversal. So that's all from this particular video. I hope this video was helpful. In case of any doubt, please feel free to put it out in the comment section, and just like, share and subscribe. Thank you.